And another big thing is that if n is greater than 21, sorry guys, if n is greater than 21, right, the absolute difference is going to be positive. If n is greater, because n is greater than 21, we have to keep it positive, right? So since n is greater than 21, it has to come in the beginning. Yeah. Okay. And then we have allowed talking parrots. The hour parameter is the current hour time in the range of 0 to 23. We are in trouble if the parrot is talking and the hour is before 7 or after 20. Return true if we are in trouble. So we're going to translate this one again, okay? So if the parrot is talking, we don't really need that. If talking and the hour is before 7 or after after 20. So and hour is before 7 or um, hour is greater than 20, right? Then we are in trouble, so we return true. And otherwise, we are not in trouble. Um, and another big important thing to remember is that since the order of operations is a little interesting in Python, you have to make sure that it's checking these things in order. So right now, what it checked just now is if talking and hour is less than 7. So we don't want that, right? We wanted to check talking first, just talking. And then we wanted to check if either of these are true. Okay. So moving forward, makes 10. So we're given two ints, a and b, and we return true if one of them is 10 or if the sum is 10. Okay. So if one of them is 10, so if a is 10 or b is 10 or a plus b is 10, then we return true. Otherwise, we return false. And this is one of the cases where we don't really need to put an else statement, right? Pretty straightforward stuff. So given an int n, return true if it is within 100 of 10 of 100 or 200. Okay. So this is actually solvable in one line. So return, and then we'll do ABS 100 minus n equals or is less than or equal to 10. And then we'll do that, or ABS of 200 minus n is less than or equal to 10. And that works because we're just checking whether the absolute value of 100 minus 10 is less than or equal to 10. So this is literally just finding the difference between these two, and then if it's negative, it's just turning it positive, obviously, right? And if that's less than or equal to 10, so if it's within the allowed range, then we're going to return true. Same thing for 200, okay? Okay. Given two int values, return true if one is negative and one is positive. Except that the parameter negative is true, then return true only if both are negative. So if we'll start off with negative. If negative and a is, so in order to check if it is negative, we can just do something interesting. So what we can do is we can do or sorry, that's for positive, but I'll explain that later. And a is less than 0 and b is less than 0, then we return true. Elif not negative, and we have to make sure that one is negative and one is positive. So the cool thing that we can do is we can multiply a and b. And if this is less than 0, then we're good. And the reason that this works is because if you multiply a positive number and a negative number. It doesn't matter which one is which, right? We will always get a negative number. That's just simple math, right? So yeah, that's just a math concept, right, that you can apply. So this is also true. Okay. And then, otherwise, we're just going to return false. Okay. Not string. Given a string, return a new string where not has been added to the front. However, if the string already begins with not, return the string unchanged. So if the string already begins with not, so what we're going to check is if the length of the string is greater than or equal to 3, which is the length of not, and the first 3 letters of the string are not, then we just return the string as is. Okay, we don't need to change anything to it. Otherwise, we have to add not. So we're going to return the word not plus the string. Okay. Um, sorry. Greater than or equal to 3, and sorry guys, I sometimes think faster than I type. So yeah, that is not string. Okay, missing char. Okay, so given a non-empty string and an int n, return a new string where the character at the index n has been removed. So the value of n will be a valid index of of a char in the original string, i.e., n will be in the range 0 through length of string minus 1 inclusive. That last sentence might have been a bit confusing. All that means is that the index of the string is guaranteed to be within the string. It's not going to be like, if for example, if we have a string of length 5, the index is not, we're not going to be given index like 200, right? It's going to be in the string. So for this one, we will do return, and then we'll do str of 0 through n because the ending is exclusive, plus str of n plus 1 onwards. Okay, and then this will just do everything but n. It'll give us everything but the character at index n. Okay, front back. So given a string, we have to return a new string where the first and last characters have been exchanged. So for this one, if the character is, if the string is less than or string length, sorry, is less than or equal to 1, then we just return the string itself. Because if you think about it, if we're given an empty string, we can just return that. If we're given a single character, there's no, even if you exchange the first and last characters, like it's just the same string. So yeah, we're gonna do that if it's 1 character long or 0 characters long. Otherwise, what we're gonna do is we're gonna return. This is a little tricky. So str of last character plus str of 1 through length of str minus 1 plus str of everything until 1. Okay, which is basically str of 0. Oh, sorry, I meant to put the colon right here. So basically what this does is it says, okay, if it's not less than or equal to 1, I want you to start at the last character and move all the way towards the end. So it's just going to grab the last character basically. And then it's going to grab everything from the first character all the way to the second to last character. And then finally it's going to add the first character. So it's just swapping the end positions, right? Pretty straightforward. Okay, front 3. So given a string, we'll say that the front is the first three characters of the string. If the string length is less than 3, the front is whatever is there. Return a new string where which is 3 copies of the front. So front is going to equal str of everything to 3. Okay, and we're going to return front plus front plus front. And the reason that this works is because even if this does not go all the way to a third character or index 2, right, it's not going to give us an error. Okay, that's the great thing about this, is that even if we don't have 3 characters, it's not going to give us an error necessarily, which as you can see, it works here. Okay, so that was warm up 1. Hopefully you guys understood most of it. Sorry, I got confused with Java a few times, but yeah, let me know if you guys have any questions. And then we're gonna move on to warm up 2. Okay. So just to give you guys a taste of warm up 2, which is going to be the next homework, I'm going to do the first problem for you basically. And so in this problem, string times, we're given a string and a non-negative int of n. And we have to return a larger string that is n copies of the original string. So it's kind of like the problem that we just did. So for this, we have to make a new variable. We're going to call it out. Okay. And then we have to use our knowledge of for loops for this one. So we're going to do for I in range of n out equals out plus str. Okay, so it's going to add n many strs to out. I hope you guys understood that. I'll repeat it just in case. We're going to add n number of strs. Okay, so if high is str and 2 is n, then we're adding 2 highs. Okay, that's our output. And then we're going to return this. So return out, right? And as you can see, we get it all correct. So yeah, this is just a taste of warm up 2. There's going to be a lot more, right? Yeah. So warm up 2 is just medium warm up string list problems with loops. And there's solutions available in case you need help. But please try not to depend too much on this solutions, guys. I know they're there, but they're really only there if you absolutely need them. So yeah, that is it from me. Hopefully that helped you guys out if you had any problems or questions about the homework. And now I'm going to pass it off to Esther, who is going to go over classes and objects first.
Let me screen share. You see it? Right. Okay. So this is Python class and objects. And so Python is an object, Python is an object-oriented programming language, just to start off with. And we use class as an object instructor. It's kind of like a blueprint for creating objects. So first of all, creating a class. So to create a class, we use the keyword class. And it says in this example, create a class named myClass with a property named X. So basically to create class, we just put class and then the name of the class name, which is myClass in this example. So if we have it here. we have my class is equal to my class colon, and then here there's the indentation, and then we do x is equal to 5, and then we just print my class. So we can always change the name of my class to, blue. It's just like a random name. And it will still do the same thing. So just class is just, just the name of the variable. So I mean just the name of the class. So you just use the class to make a class, basically. So when creating objects, we use the class name, in this case, my name, to create objects. So basically here we're creating an object named P1, and we print the value of X. So let's take a look at this example. So class, my class, so that's the class, we're using the class keyword, and we're naming the class my class, and we give it the value x is equal to 5. And then, like the example said, it says to create an object named P1. So we're creating an object named P1 is equal to my class, and then we're just printing P1.x. So if we do that, it's just going to print 5. So we're just printing objects in this example. We're using objects to print the value of x, which is inside the class. So this is the init function, and yeah, so we usually use this. So all classes have a function called init, and we end it with parentheses, which is always executed when the class is being initiated. So we use init function to assign values to object properties or other operations that are necessary to do when the object is being created. So basically, I'll explain while looking at this example. So to create a class named person, so in this example, we're creating a class named person, which is right here, and we use the init function to assign values for name and age. So as I said before, the init function is to assign values to object properties and other operations that are necessary to do when the object is being created. So basically, we're using the init function to assign values to object properties. That's basically what you have to know. So here, we're just going to assign values for name and age. So we have a class here, which is called person. And we have a function here, def. That's how that's how you name or how you make your function. So we make the function init, and the inside we put self, name, age. I'll explain what self is a little bit later, but you just have to know that we're putting name, age in this example, and self.name is equal to name, self.age is equal to age, and then this is our object name, and P1 is equal to person, and then we just put our values here, and then we're just printing P1.name and P1.age. So you're just going to print the name and the age. That's, yeah, it looks pretty complicated, but it's pretty simple. So you have name, which is John, and age, which is 36. So you're just plugging those stuff in. So if you run it, you just print John and then 36. And just a quick note, init function is called automatically every time the class is being used to create a new object. So whenever you use a class to create a new object, kind of like you're using a class to create a new object, like basically the one that we just did, you have to use the init function to do so. Okay. So next is the string function. So the string function controls what should be returned when the class object is represented as a string. if the string function is not set, the string representation of the object is returned. So the string function controls what should be returned. So it controls what should be returned when the class object is represented as a string. So the examples that we looked at, there were some integers, and I don't think we've encountered string yet. But whenever you encounter string, you have to use this function. So let's take a look at this example. So we have class, that's the class name. And then we obviously, like we said, we always have to put the init function to make a object inside a class. And so we're calling the init function, and inside we're just going to use the same thing. Self.name is equal to name, and then self.age is equal to age. So name and age you're inputting, and it said you're doing P1 is equal to person, John, comma 36, and then you're printing that. So if you print it, you're gonna run main person object at whatever this is. So that's basically the example. That's an example of string representation of an object without the string function. Okay, that's without the string function. So because there's no string function, there's this whole thing that like comes out as like a weird thing. But if you add the string function, it's more organized, as you can see on the right side. So the difference is here you have the class and the class name, which is the same, but inside you have the init function and you have this, which is all the same. Just this part is different. Def, and then you use the string function, you're calling the string function, and you put inside self, and then return f parentheses squiggly bracket self.name and then self.age. So this is the format of the string function, and if you type it in like that in the code, then it will print it like John 36 instead of a person object at whatever that number. So yeah. So moving on to object methods. Objects can also contain methods. Methods in objects are functions that belong to the object. Okay, that's pretty straightforward. So let us create a method in the person class. So we're going to create. So if we use class person, what we've just been using, and if we call the init function with the self.name, self.age, and we call insert a function that prints a greeting and executing on the P1 object. So we're calling a function called myfunc, and that inside the parentheses there's self, and we're printing hello my name is, and then plus self.name, and then P1 is equal to person John, comma 36, and then P1.myfunction. So what they're basically doing in this example is they're inserting a function. So inserting a function that prints a greeting, which is right here, and then they're executing it on the P1 object. So that's literally what they're doing. They're just putting it inside the P1 and .myfunc. So if you do that, then it's just going to print hello my name is John. So hello my name is, and it takes the self.name, which is already said to be the name, which is John, and your P1.myfunc, that's basically like a print statement in this case. So yeah, you're just combining the whole thing into one. It works the same as a string. So the self parameter is important because, as you can see, it keeps coming out. It's on every single example, I believe. So the self parameter is a reference to the current instance of the class and is used to access variables that belong to the class. Class and is used to access variables that belong to the class. So yeah, it's just like a keyword, I guess, to replace something instead of plugging the value in right away. It's the current instance of the class and is used to access variables that belong to the class. So you're just using it as like before calling the real variable name. It just works for anything if you just put self because it's not assigned to anything yet. So yeah. So the self parameter. The self parameter is a reference to the current instance of the class and is used to access variables that belong to the class. So we kind of went over that. It's very similar to just self itself. It does not have to be named self. As you can see, it's kind of like a variable. You can call it whatever you like, but it has to be the first parameter of any function in the class. So use the words my silly object and ABC instead of self. So here they're calling the class person and then init function. So here on the other examples, the word self went in here, but in this case we're putting my silly object. That's just the goal of this example to show you that the name of self doesn't have to be self. It can be anything else. And then you're setting that to dot name. You're setting that to dot age. And then here too, instead of self, you're putting ABC and then abc.name. So if you're gonna use a name though, like pretend you want to use apples. If you want to use that as your name, you have to use it throughout. You can't just say apples, apples, and all of a sudden use my silly object. That doesn't work. So you just have to use that throughout. But yeah. So the name doesn't really matter. Okay. Modify object properties. So you can modify properties on objects like this. So here we're setting the age of P1 to 40. Okay. So right here, P1 dot age is equal to 40. That's just we're just like modifying properties. So it kind of works like variables. We used to have like a variable name, like let's just say my variable is equal to 10. Like you're setting something equal to a value. That's how you made a variable name, and you're just doing the same thing to the age here. But yeah, so the original value of the age is 36. However, they're modifying it to 40. So it's kind of like you already have a my variable is equal to 10, but I guess you're updating it to my variable is equal to now 15. So it's the same thing. You're just modifying, and if you want to modify it, you just want to access it. So p1.age is equal to, right now it's changed to 40, but I want to change it to 36 again, and that's how you can do it. So let's just say 36 now. If you get rid of it, it should say 40. So yeah. So, you could delete object properties as well. You can delete properties on objects by using the del keyword, okay, del, and delete the age property from the p1 object. So I don't know if we learned del yet for other stuff, but um, anyways, we use del to get rid of it. So if you use del of this age, then like it says, it deletes the age property from the p1 object. So it's pretty straightforward. You're just deleting it. And see, as you can see, if you delete p1 age and if you print p1 age, since you're printing something that's deleted, it's going to give you an error because person object has no attribute age, right? Because you deleted it. So if you get rid of this, let's just change it inside a comment. It's not going to give you an error. It's going to print 36, but because you deleted it, it's basically now erased from the code. It's going to give you an error. It has no attribute age. You can also delete objects. So it works the same way. You delete objects by using the del keyword. You delete the p1 object. So we're deleting the p1 object. If you delete it, like I just went over, p1 is not defined because we're deleting it from the code. So if you print p1, it doesn't exist. So you're printing something that doesn't exist, and that's going to print an error. And the pass statement, we went over this yesterday, I believe. But class definitions cannot be empty. But if you, for some reason, have a class definition with no content, it just has no content, put in the pass statement to avoid getting an error. So basically, if you just don't want anything, I don't know, like for instance, you just don't want to put anything. If you leave it like this, it's going to give you an error because you just have an empty class, which you can't have. But if you put pass, it's just storing something. It's not storing anything, but it's storing something where it doesn't give you an error. It's just gonna load and give an empty screen, like empty black screen. So like it says in this comment, having an empty class definition like this would raise an error without the pass statement. So this pass statement is just there so that it doesn't become an error. Yeah, so that it passes, I guess. I guess we can try these examples. If you guys want to tell me in the chat or yes, yeah. So create a class name my class. Class goes in this. Very good. But this one, class my class x is equal to 5 will be the answer. P1 is equal to my class parentheses. Very good. Yeah, so P1 is equal to my class parentheses. Yes, that's the answer. Use the P1 object to print the value of x. Anybody know this one? Yeah, P1 dot x. Yes. Yeah. Okay. And then last one. What is the correct syntax to assign init function to a class? I guess I didn't really go in depth to this, but it's init, but there's the underscore thing. Yeah, I think that's what I printed out. Yeah. So yeah, that's basically how it looks. So yeah, nice. Then since I think we can move on to the next section. And that'll be inherited. Yes. So inheritance allows us to define a class that inherits all the methods and properties from another class. So I think this is kind of complicated, so yeah. Parent class is the class being inherited from, also called the base class. Okay, so you're inheriting from the parent class. And then child class is the class that inherits from another class, also called derived class. As you can see, base class, derived class, it kind of makes sense why it's called that. So let's start with creating a parent class. So any class can be a parent class. So the syntax is the same as creating any other class. Any class can be a parent class, so the syntax is the same as creating. Yeah. So yeah, any class can be a parent class, because what parent class is a base class is the class being inherited from. So that can be anything. That can be any class. That's why the syntax is the same as creating other classes. So we're gonna create a class named person with first name and last name properties and a print name method. And to create the class, as you can see, it's the same thing, class person. We don't do anything different when creating parent classes. We call the init function, self first name, self last name, print self first name, self last name. And this says use the person class to create an object and then execute the print name method. So that's what they did here. And yeah, so basically parent class is no different from creating a class. You're just making a class. It's the same thing. And let's look at a child class. To create a class that inherits the functionality from another class, send the parent class as a parameter when creating the child class. So we're sending the parent class as a parameter when creating the child's class. So what this means is we'll go over what this means by looking at this example. It says create a class named student, which will inherit the properties and methods from the person class. So what they did was they said class student, and then they did parentheses person, and then they passed it. So they just passed it so that it doesn't make an error like we went over, and class student. So as you can see, that's the new class name. That's basically the child class name. And inside the parentheses, we're putting the class that we're inheriting from. That's the parent class, okay? So it's important to know the difference between a child class and a parent class. So no, use the pass keyword when you don't want to add any other properties or methods to the class, what we just went over. Now the student class has the same properties and methods as the person class. Yes. So if we do this, if we do student and then person inside, then the student class inherits basically everything from the person class, which is the parent class, and then yeah, it's just gonna have the same thing. Okay, let's try this one. So this is like a very good example of like everything I just said for the last 2 minutes. So class person, it just has the class person inside. However, it says class student person, right? You want to inherit everything from the person class for the student class, and you pass it and you're printing it. So let's see, if you print it and the student is Mike Olson, x dot print name, it's just going to be the same thing. You can see. So now we're adding the init function to this. So far we have created a child class that inherits the properties and methods from its parent. We want to add the init function to be function to the child class instead of the pass keyword. So now we want to really do something with the child class instead of just making a class and not doing anything with it and just calling pass. So just a quick review. The init function is called automatically every time the class is being used to create a new object. Like we went over, the init function is, yeah, basically what it says here. It's called automatically every time the class is being used, okay? To create a new object. So we add the init function to the student class. So we have class student and then person. Remember, we're inheriting from the person class. And then def init function, we call the init function, and same parameters go inside the parentheses. And then you add whatever you want the init function to do. So this is add properties, etc. So yeah. When you add the init function, the child class is no longer inherit the parent's init function. So this is very important. Once you call the init function for under the student's class, although you're inheriting from the person, because you have a new init function for the student now, you no longer inherit the parents' init function, okay? So the init function of the person that you're inheriting from is no longer yours, if that makes sense. I'll do an example here. So to keep yeah. Yeah, let me just explain that one more time. So, because you have a person inside the student's class, this part, it makes you inherit the parent's class into the student's class. However, the student class is calling its own init function, therefore, the child class will no longer inherit the parent's init function. And then just to note, the child's init function overrides the inheritance of the parent's init function. Yes, also word overrides. So it's like overriding. Yeah. However, there's also a way to keep the inheritance of the parent's init function, okay? And add a call to the parent's init function. So what if you want to keep it, right? You want to keep whatever you inherited. Add a call to the parent's init function. F name. Yeah. So to keep the inheritance, we add a call to the parent's init function, and we see that here. DEF here, and it says person dot init self f name l name. So we're, as you can see, under the init function of the student, we're adding the init function of the person by doing person dot init with the same parameter. So that's why you're keeping it. You're just adding the function again to keep it. And then we have successfully added the init function and kept the inheritance of the parent class, and we are ready to add the functionality to the init function. Yeah. So now we're going to use the super function. Python also has a super function that will make a child class inherit all the methods and properties from its parent. So there's a function called super function where you can basically inherit everything from the parent. So here you do class, student, and then person. You call the init function, and then if you call the super dot init f name and l name, which is first name, last name, and you call it, you're going to inherit everything. So Michael, so you're just going to print the same thing because you're inheriting all the methods and properties from its parent, okay? So that's the super function. So by using the super function, you do not have to use the name of the parent element. See, here you want to keep the inheritance of the parent class, so you're using the parent class class name, but here you don't have to use the name of the parent, you just have to use super because it would automatically inherit the methods and properties from its parent. So super, if you just don't want to type the whole name out, it's going to do the same thing. To add properties. So you can add a property called graduation year to the student class. So let's add properties. So as you can see, we're using the super function now, and we have self.graduation year is equal to 2019. I'm gonna just change that to like 2024 because yeah, for seniors, I guess. And we just have dot graduation year, and then if you run it, it should print 2024. So you're just adding more properties into the function now. Yeah, you're just adding stuff in. And then in the example below, which is here, the year 2019 should be a variable and passed into the student class when creating student objects to do so, add another parameter in the init function. So we want to add another parameter. So if you want to add another parameter, it's easy. You just, these are parameters. So you just put a comma and then you just put the name of the parameter. I don't think I have to do this example because I think it's pretty straightforward. And if you want to call it, then you just do self.graduation year is equal to year. And then, yeah. So we can also add methods. I think that's like the last part of the inheritance. So add a method called welcome to the student class. So to add methods, what they do here, they have the same thing, and then here df welcome parentheses self. That's the welcome function, and then print welcome self first name to the class of self dot graduation year, and then we're creating self, and then we're method called self welcome to the student class. Yeah, so we're just calling the method to the student class, and we're printing the whole statement. So if we run it, it should print welcome Mike, self first name, which is Mike, self last name Olson, to the class of self graduation year 2019, and that's what it prints. So yeah, we finished this section. Let's quickly go over the exercise. And if you guys can try doing the exercises and like send it in the chat. So what would be this one? Create a class name student that will inherit properties and methods from a class name person. Yes. So it would be student person. Good. Yeah, and it just, the SMP just has to be capitalized because that's just what they want. Yeah. How about this one? We have use student class to create an object named X. What is the correct syntax to execute print name method of the object X? So it's actually X print name parentheses. That's correct. And yeah, the order matters. The print, yeah, the order matters. So you always want to put the object name first and then dot print name, whatever you want to do. Okay. Oh, any short answer, but yeah, that was correct. So yeah, then I'll move on. Next one, which is iterators. So Python iterators. Okay, an iterator is an object that contains a countable number of values. So an iterator is an object that can be iterated upon, meaning that you can so basically let me okay. So yeah, so it's an object that can be iterated upon, meaning that you can traverse through all the values. So basically you can like cross through all the values. That's basically what it means. So technically in Python, an iterator is an object which implements the iterator protocol, which consists of the methods iter and next. So this is pretty familiar to us. It's basically the iter function. Was it not iter? Iter function, and then we have next. Okay, so these are the two methods that we are going to use. But first of all, iterator versus iterable. Okay, it's different. So lists, tuples, dictionaries, and sets are all iterable objects. They are iterable containers which you can get an iterator from, okay? From these objects, all these objects have an iter method which is used to get an iterator. Okay, so to get an iterator, you use the method iter, and if you iter through it and you just type next, I guess, then it's just going to iterate through the tuple, in this case, so apple, banana, cherry. Okay? Even strings are iterable objects and can return an iterator. Strings are also iterable objects containing a sequence of characters. So in this case, it's going to print by letter if you iterate through the my string, and if you just iterate through the string, it's going to print. It's going to iterate through the letters. So we can loop through an iterator, and so we can also use a for loop to iterate through an iterable object. Okay, so iterate the values of a tuple. Okay, so my tuple is equal to, parentheses, apple, banana, cherry. That's a tuple, and we're using the for loop for x in my tuple. That's the index, and we iterate through it, so we're just going to print apple, banana, cherry. As you can see, this example is printing the same thing as this example. Okay. And then iterate the characters of a string. You can use a for loop also, and iterate through the letters. The for loop actually creates an iterator object and executes the next method for each loop. Okay, it's just using the next method without having you call it, which is a lot more convenient than calling next. So to create an iterator, to create an object or class as an iterator, you have to implement the methods iter and next to your object. So now we're going to finally use this method. And as we learned in the previous chapter when we were talking about Python class and object, there was a function called init, right? Sorry, it wasn't iter, it was init, which allows you to do some initializing when the object is being created, right? That's what it was doing. However, the iter method acts similar. So iter method is similar to init. You can do operations such as initializing, which is what init does, but it must always return the iterator object, okay, itself. So I'll explain that more in detail after I read what next method does. So the next method also allows you to do operations, and you must return the next item in the sequence. So let's look at this example. Create an iterator that returns numbers starting with 1, and each sequence will increase by 1, returning 1, 2, 3, 4, 5. Okay. So you have class my numbers, and then you use iter self, and then inside you're using self.a is equal to 1, and then you're returning self. Okay. So you're literally creating an iterator right here using these two methods, okay? And it's in this example, you're iterating from 1 all the way to 5, I believe, or I think it just keeps increasing by 1. Yeah, it just increases by 1, and then you also make a next iterator, and you make it x is equal to self.a, and then self.a plus equal to 1, and then return x, and then blah 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 blah, and then you make that equal to each other, and then you just iterate through that class. So that's just how it iterates through it. yeah. That's just, yeah. So if you want to stop iteration, um, when we used to stop iterations in for loops or while loops too, but the example above would continue forever. Like this example that we went over, since we're returning from 1 and then it's adding 1, it's going to go forever. 1, 2, 3, 4, 5, and it's going to go 6, 7, 8, 9, 10. And it's going to go forever and ever until you stop the loop, because it's a for loop and it's gonna continue until the statement is false, right? Or it's out of the count that you want it to loop through. So to prevent the iteration from going on forever, we can use the stop iteration statement. So there is a statement to stop the iteration, which is stop iteration. And in the next method, we can add a terminating condition to raise an error if the iteration is done a specified number of times. So this is an example. So they want to stop after 20 iterations, right? So we do the same thing here, but if you see here, there's a condition if self.a is less than or equal to. So if it's 20 or less, then it's going to add 1. However, else you're going to raise self iteration. So if it goes over 20, like 21, 22, 23, those are all over 20. It doesn't satisfy the condition, therefore it will stop iteration. It will enter this else statement and it will stop the iteration. So it's pretty straightforward. You also have to remember that the stop iteration goes inside the next method, which terminates the whole condition. Okay. And oh wow, yeah, that's it for this section. And then I'm pretty sure this one is also part of today. Yes. So Python polymorphism. The word polymorphism means many forms, and in programming it refers to methods, functions, operators with the same name that can be executed on many objects or classes. Okay? So function polymorphism. An example of a Python function that can be used on different objects is the len function. And I believe we used the len to count tuple, list. We used it before, I believe. So for strings, len parentheses, the len method returns the number of characters. So what it does is just, if you want to count through the string, you don't want to, there are going to be, I guess, like hello world exclamation mark, that's pretty countable, but you're going to have like, sentences that are long, and it's going to be, just like, it's very not necessary for you to count it. So therefore, you just run it, putting the len, and you put the variable name. And if you run it, then it will tell you the length of the string, the variable x. So if you put a space, the space counts as a part of the length, I guess. So yeah, the strings count. So yeah, I guess that's pretty useful to keep in mind. And you can also have numbers. Obviously, it's a string. And yeah. The length of tuple. Okay. And I may just enlarge this. So the length of tuple. For tuples, len returns the number of items in the tuple. So for tuple, we're not counting the letters like we did in string. We're just counting the number of items in the tuple. So in this case, it's countable 1, 2, 3, apple, banana, cherry. So there's 3. It should return 3. And like string, if we can add like pair, orange, and it should now return 5. So there are going to be times where it becomes really like a burden to count them, so you can just use len my tuple. And yes, yeah. Dictionary. So for dictionaries, len returns the number of key value pairs in the dictionary. So as you can see, key or value pairs in the dictionary. You're counting them by pairs. So you're not counting this by 1, 2, 3, 4, 5, 6. You're counting them by 1, 2, 3. Okay, so you're counting them by pairs. So right here, brand colon 4, that's the key, that's the value, that's the key, that's the value, that's the key, that's the value. So you're just going to count them by key value as 1. Okay. And then class polymorphism. So if we go into class with this, polymorphism is often used in class methods, okay? So where we can have multiple classes with the same method name. So for example, say we have 3 classes, car, boat, and plane, and they all have a method called move. Right? So different classes with the same method. So let's see here. Oh, I see. So we have the class car, and then we have the init, and we have, other different properties in here, but it says df move, and you want to print drive. So there's the move function here, move method here. And then they also use it in move method inside the class boat, and they also use it inside the class plane. And that's all possible to do because polymorphism, it just means, many form, and it can be used in many kinds of class. And it can be used in many kinds of class methods. So you can have multiple classes with the same method name. That's just all it's saying. So yeah, this repeats 3 times, and that's fine. So inheritance class polymorphism. So what about the classes with child classes, right? With the same name. Can we use polymorphism there? And the answer is yes. If we use the example above and make a parent class called vehicle and make car, boat, plane, child classes of vehicle, the child classes inherits the vehicle methods but can override them. So we're going to use parent classes and child classes inside this. So if we have a class called vehicle, that's going to act as our parent class, right? So we have the parent class, and then we have the child class. Car, boat, plane, child classes of vehicle, right? So we have a class right here, and it has vehicle in here, boat, and it has vehicle in here. However, we're going to override these two with these for boat and plane because, as I said before, the child classes inherits vehicle methods, however, it can override them, right? So that's just basically what it does. I'll just repeat that one more time. So, although it has the same methods, that's okay because that's just what it can do. It can do that. It can have multiple ones with the same method names, and it can have it can have more child classes inheriting from the parent class with the same method also, and then those child class, the properties will override the parent class. And then just last few things, child classes inherits the properties and methods from the parent class. And then in the example above, you can see that car class is empty, but it inherits brand, model, move from vehicle. So the boat and planes classes also inherit brand, model, and move from vehicle. However, they can both override the move method, right? Because polymorphism, we can execute the same method for all classes. And yeah, so that sums up polymorphism. And yeah. So let me stop sharing. And I think I hand it off to Ian.
Okay. So, the next couple of topics that I'll be talking about are, so first of all, I'm gonna be talking about scopes. So let me just share my screen. Okay. Okay, so scopes are basically different regions. You can kind of you can kind of think of them as like different sections of the code, and depending on where you put certain things, people who use the code can access them differently. So the first, I guess, type of scope that I'll be talking about are local scopes. So local scopes are variables that are inside of something called a local scope of a function, and whatever is inside that scope can only be accessed. The only things that can be accessed are from inside that local scope. So I know I'm not really making sense right now, but okay. So first, what this code is kind of doing is you first define the function of, and then they just kind of named it my function, and then they put the x inside of my function. So what that did was that um, they treated this as like a local scope, and they put this inside that scope so that whatever, like let's say one person was to access this function, then they could only access the x value. So since x is 300 and you printed x, it's going to be 300 obviously. And depending on like whatever value, like 900, then this would run like 900. Yeah. So pretty simple for this one. So the next example I'll be covering is a function inside of a function. So if you take a look at this example, it's similar to the previous one, but so the part that is similar is this part, and the part that is different is that there is a new function called my inner function, or my inner func, and you printed x from that is nested under the my inner func. So what that did was you first defined x inside myfunc, and then you have a separate function inside of myfunc, and you printed x inside of my inner function. So what that did was, because you defined x previously, so whatever's under the myfunc you can access within that. So depending on what you change that to, again, it's also going to be 500. This is like, this concept is very flexible, I would say. So depending on where you nest things under, people can access things differently. Okay. So that's it for local scopes, and the next type of scope is called the global scope. So as the name kind of suggests, local is more localized, meaning it's inside of something, but then a global scope is more like outside, and it kind of mentions things before things are defined. So what that means is, before any function is defined, right, you first define x, or just any variable you want to use in general. It doesn't have to be x, you can use y or anything else. But you're going to define your variable, and then you're going to mention a function. So so in this case, x is 300, and you define myfunc, and then you printed x. And then there's also myfunc, and then you also print x again. So what that did was that, because you defined something previously, so because these all look to this when the function is run, And then there are two print statements in between. So you're gonna print two 300s. So again, if you change that up, then it's also gonna be two 500s. That's because this is something that's called a global scope, and that kind of just has like a overall meaning of, oh, this is something that is over everything, and whatever falls under that, it's gonna be defined. Um, yeah, so that kind of shows the difference between the local and global scope. And another example
Oh,
is okay. Okay, so this kind of combines the local and global scope function. So what this does is that it first defines x as 300, and then there's another function, and inside there's x, right? And then this lists a new value for x. So if you see what I highlighted, my func will define only this part. So if you look at what's printed here, it'll first print the X. So if you look at the highlighted region, 200 will be printed first, and then you'll move on to the global sense. So you'll look at the whole thing and you see the print statement at the end. So since this can't really access this, since this is localized to only that region, then it'll look to this 300 and print 300. So yeah, that's like the combination of it. And one thing you can do is use something called the global keyword to rename something. So yeah, so you can use that to change something that is local and make that global. So without the global here, like without this part, this would be a local function, right? But then because this example used the global function on the x, this became globalized. So what that means is if you look at the highlighted region, let's say this wasn't here, right? Then this would be only a local function, but then since I put the global, this print function can access what's inside the local function because it's been globalized. So this would print 300. So that's kind of the global keyword. Um, let's look at another example. Okay, so x is defined as 300. So this is the global function, right? And it defined my function first, and then if you look at this region, this is the local function, but they used a global keyword and made this local function into a global function. So when they look to print it, whatever was later defined, than this one, they Python tends to look at whatever is defined later. So when they printed it, they printed 200 instead of 300. Yeah. So yeah, that's all for scopes. If you guys have any questions, please feel free to leave them in the channel. Um, yeah. So that's all for scopes. Next I'll be talking about modules. Okay. So okay. First of all, a Python module is similar to what is called a code library. So it kind of has a list of or a set of functions that you can add to whatever like application or whatever like program you're coding. So this will make more sense when we take a look at more examples later. So first, let's look at how to create a module. So I'm gonna show you something here. This is Okay, so let's say I'm coding something in main.py, but if you want to create a module, then you want to create a new file and then name something um, that pertains to whatever is listed inside your new module. So in this case, I name my thing my module.py. So it is very, very, very important that you include the .py because that's how you name a Python file, or else it will be stored as a text file and you won't be able to access the module like you want to. So inside in this example, or this is kind of what this W3 schools will use in like the rest of the lesson. They created a new module called mymodule.py, and then just keep in mind that inside the module, this code is what is included inside my module. So just keep that in mind. So how to use a module? So first, you're gonna use something called the import statement. So okay, so remember that we said that it was my module.py. So when we go back to this code, you're gonna do import and then you're gonna say my module. You don't need to include the .py, but you're just gonna say import my module, and then when you're accessing things inside of that module, you're gonna restate the module. So in this case, my module, and then you're gonna follow it up with a dot and then greeting or something like that. So here, there was a thing called greeting here. So you can say dot greeting and then you can say Jonathan, because Jonathan in this case is the name, and then they kind of made up a name. So this would say hello, comma Jonathan, because in this module they said hello plus and then name, and then if you look at this, they defined that name as Jonathan, so it's gonna say hello, comma Jonathan. Okay. Okay, so variables in a module. Variable or a module can contain functions, but it can also it can also contain arrays or dictionaries or other objects, lists, etc. So I kind of did like an example here. So this is the example we will take a look at here. So first, my module.py, this code is inside that. So I'll show it in the IDE. So in this, if you see here, my module.py, I have this inside the my module.py. And if you remember what we said before, in order to access this module, you're going to use import my module. And then depending on what you want to access, so if you take a look back at this, there's name, age, and country. So you can kind of see this as like a profile for a person right now. Okay. So you're gonna say A equals my module dot person, and then I want to know where that person is from. So I'm gonna say country, right? The country, and then if I run this, then I'm gonna get Norway because um his the module stated that he was from Norway. Same thing, let's say I want to know his name. Then I'm gonna say name, and then I'm gonna run that. Then his name would be John, because give me a sec. Is it said his name was John, and depending on like what you add here, so you can add a bunch of other things about that person, like I don't know, like what would a typical profile of a person contain? Um, so name, age, country, etc., etc. And you can um, rename this to uh, basically figure out what you want to know about that person in this case. Yeah. Okay, so I covered up to here. Okay, and then when you name a module, again, you have to have that .py. So you can name it whatever you like, but you always have to have the .py. And other than manually like renaming the module, so I can just go here and click rename. How you can do that is first you can say import my module, and then you can have as, and then you can rename it as mx. So what that as does is it renames the Python file that we named as my module as mx. So I can do that here as mx. So I can say that. And then what that does is for future, when we refer to this in the future, you can't use my module anymore. You have to refer it to as mx. Okay. Yeah. And then built-in modules, there's something called a platform module. What that does is so whatever like computer system you're on, what platform does is it kind of gives you like a rundown of like your system. So if you have like Windows, it'll give you like things about your computer. So if you access the platform module and then you want to like see the system of it, it's gonna say Windows, something like that. But yeah, platform is something that's called a built-in module in Python, so you can use it whenever you need to and whenever you'd like. Okay. The next is the dir function. So what that does is, again, looking at the platform module that we talked about earlier, the dir will list all the defined names that are inside the module. So I know this is like kind of like nonsense here, but if you say dir platform, and then you print the x that was a variable for this, then it'll list all the different like things in that platform. I don't know what these things are per se, but depending on what like module you import, then the dir can be very useful. Um, Looking back to like the example about the human profile or the person profile, if you want to know like everything about that person, not just one particular thing, you can use a dir function, um, and that will just give you everything or like a list of things about that person. Okay. So yeah, that's the dir function. And yeah, so just a couple like a simple note, the dir function can be used on all modules um that are like built in, but also you can use it for the ones that you create yourself. So what that means is like the one we created earlier, the my module.py. Like I said, just now, you can use the dir function and you can just figure out things about that person. Um Even though you've created it yourself and it's not a built-in module like platform. Okay. Um Okay, so import from module. So you can choose to import just parts of that module using the from keyboard or keyword, sorry. So if you don't want everything from the module, so like let's say you have the platform thing and then you don't want everything from the platform, you can just pick out things you want from that. So here um, okay, let me just copy and paste this. I think this might be easier to visualize. So my module has this information here, and then my main.py is going to have this. Okay, okay. Um, okay. So what that does is from this, I'm gonna import person one. Okay. So here it has greeting and person, but I only want person in this case. So I'm gonna say from my module import person one. So in this case you can excuse me, you can only access information about that person one. So if you print person one and then their age, if I run that, then I'll get 36 because the age is 36, and same thing about the other information as well. Okay. Okay, so yeah, that's all for Python modules. Let's do a couple of exercises to just refresh on the knowledge. Okay, So the first question is, what is the correct syntax to import a module named my module? Yeah, so in the Q&A channel, if you guys have answers to that. Yeah, okay. So yeah, it is import. Good job. Okay. Next question. If you want to refer to a module by using a different name, you can create an alias. What is the correct syntax for creating an alias for a module? Yes, good. It is, yes. Ooh, it is as. Okay. Third question was the correct syntax of printing all variables and function names of my module. Import my module and then print and then blank. Just wait a little bit more for people who are still typing. Yeah, I think most of you guys did get it. So it is going to be dir and then parentheses, my module, and then close the parentheses. Okay. And then last question, what is the correct syntax of importing only the person one dictionary of my module? So just try to fill in these two blanks. Okay. Yes, so it's going to be from and then import. Good job. Okay. So that's all for modules. If you guys again have any questions, next I'm gonna talk about regex. So regex is basically short for regular expression. Um, this can get a little confusing. So just try to pay attention. So it is basically a sequence of characters that um basically looks for things or searches for things. So again, like we talked about earlier, to use regex, we need a separate module for that. So before you use regex, you want to always import RE. So that's the module. The RE the RE is the name of the module. So always make sure to import that before using regex. Okay. So once you imported RE, okay, first of all, let's just look at an example real quick. So first, import RE, and then the text is gonna be the rain in Spain. Okay, and then what regex kind of does is these symbols. I'll talk about these symbols a little bit more later. But it will basically look for particular things in this text, and if we find a match, then we're gonna print yes, we have a match, but if we don't, then we're gonna say no match. So I know this doesn't really make sense right now, but um let's look at like these functions and it will start to make more sense. Okay. Okay. So the RE module has a lot of functions. So these four, um like if you kind of look at the names, you can kind of see what they're talking about. So find all, what that does is it literally finds all matches, um, that depending on what condition you put, it finds everything, um, that you want to look for. And then search is in between a string. So like this is a string, right? So in between the string, um, search basically looks for any match that is in between the string, anywhere in the string. Then split, it returns a list of where like the string has been split. So like spaces, for example. And then sub, it replaces one or many matches with the string. Okay. Okay. Um, Next, meta characters are characters with special meanings. So, like these things, like these symbols, are meta characters, and I'm gonna try to go over each example to make sure you guys know what each one is. Okay, so the first one is going to be these two brackets. So example of this is the text, and what this is going to do is basically whatever is within this these brackets, then you're gonna look for everything that is in between here. So when we talked about find all, um it's gonna find all lowercase characters alphabetically. So if I run that, then it's gonna look for, like, it's gonna go in order from A, B, C, D, and then it'll list them in the order we find it. So the characters like H, E are all in between AM. And then A is also in between, and then I, and then so on and so forth. So this is kind of like the syntax for it. So it's gonna be like X equals RE, and then you can do like search or like find all, and then I'll do find all, and then you can um we'll go over more meta characters, but for now, um like that, and then you're gonna put a comma, and then you're gonna do like text, depending on what this is named, of course. Okay. Okay. Next one is the single slash. Okay. So the single slash this slash D will look for all digit characters, meaning it'll look for like numbers. So in this case, this program is asking to look for all the numbers in here. So obviously these two are the only numbers, so it will result in this. And then next one is the dot, so, or the period. So what this is depending on how many dots you put here, it'll look for characters or like parts of the string that have this condition. So what this means is that it'll have HE, and then it'll have two um like letters, and then it'll end with O. So find all, and then if you Python will look at this text or string, and it'll look for the part of the string that relates to this condition. So the only thing that relates to this here obviously is going to be hello. Okay. Next is this, like, the carrot looking thing. Um it's gonna What this means is that it'll look for whether the string starts with hello. So this means start here. So in this case, the text does start with hello. So this is gonna print um this. It'll say yes, the string starts with hello. But if I were to say, does it start with planet? Then if I run that, then it'll say no match because it does not start with planet. So what this does is it always looks for what's in front of the string. Okay. And um the the dollar sign is basically the opposite of the carrot. It looks for the end of it. So um and then keep in mind that the carrot goes in front because it is referring to start, while um the dollar sign goes on the back because it refers to the end. So this will look at what is at the end of the string. So in this case, it has hello planet. And because planet is at the end, it will say yes, the string ends with planet. So that's a $sign, which means it's end. And then the next one is the asterisk. So what this does is again with the dot and the asterisk, it means that there are 0 or more characters in between. Okay. So it can have 0. So if the word was like Kyo, then it would still print Kyo. But then this can mean there's 0 characters to like just infinitely many. So it could print this as well. But in this case, it's just hello, so it just printed hello. So that's 0 or more. And then same thing, but it has different conditions. So the plus sign means 1 or more. So there has to be one, at least one character in between, or else it will not print. Yeah, so because there's 2 L's here, it will print because it is 1 or more. But this would print, but then this will not print. But yeah, so like and then okay, so the question mark is also pretty much the same thing, except um it has to have 0 or 1. So in this case, hello, there's 2 characters in between the E and the O. So this would only print if it was Hio or hello with 1 L. But because hello is spelled with 2 L's, nothing is printed here. Because the question mark only looks for 0 or 1 characters in between here. Okay. Um, okay. So the curly braces are similar, except you can list what you want. So how many characters you want in between. So let's say if I added like 2 more, and then there's how many, like four L's, then this would look for this character. But if I were to just leave it at 2, then it will not be printed because there's no 2 characters, there's 4 characters. So in this case, you can specify how many characters you want in between. I'm using the curly brace. Okay. Um, okay. Next one is it's just a line. I don't know what it's called, but yeah, it's just the line. So what this means is or. So um there's falls or stays. So it'll look for everything that refers to falls or stays, but in this case there's no stays, but there is falls. So because you can because this line means that it's either or, and because falls is here, then it will print yes, there's at least one match. Okay. And the parentheses capture and group, meaning it just groups things like this. Like, okay. And then so this is all meta characters. Um when doing regex, try to keep these in mind or like have it where it's easily accessible. So you can like go um just when you this is very useful when you look for things in the string. So if you have like a really long string and you can manually go one by one looking for things, but Python just makes it a lot easier of using these characters to find certain things. So just try to keep these in mind. Okay, so next is special sequences. So I'll just try to go by one again. Okay, so the A, um, similar to the previous meta characters, it looks for the part in the string that starts with the. And then what this does is it, unlike the meta characters, it prints out the. Yeah, so that's all for capital A. And then, oh, okay. So, B, so slash B, um, it refers to anything that is present at the word. So, behind whatever is behind this. So in this case, AIN. It checks if that is at the beginning of a word. So because AIN is nowhere to be found in front of the word, this will have no match. But um um if you look at this one, since this is, so what's different about this and this is that this part and this part. So if you take a look, depending on where the B is positioned, it will make a huge difference. So whatever is in front of the B, it'll check for AIN. And depending on where the B is, so if it's at the end, then it'll check that AIN is at the end of the words. But because the B is at the front, it'll check that AIN is in front of the words. So where you place the B depends on whether you check if it's at the front of the word or at the end of the word. Okay. So that's lowercase b, and then capital B. It's the same thing except it's, sorry, that was very contradictory, but it'll check if it's not there. So um here, AIN, it'll check that it's not at the beginning of words. So, because it is actually not in front of the words. So if you check here, there's like no AIN. They'll say, yes, there's one match. But if you put this at the back of it, it'll check that AIN is not at the end of the word. But in this case, there is AIN at the end of the word here and here. So in this case, it is no match. So just think of whatever's capital um is the not version of the lowercase one. So that's gonna be in common for everything else I talk about here. So if you look at this, so the D again is like the digit one we talked about. So if you say slash D, it'll look for digits, but in this case there are no digits here, so it'll just have no match. Um and then the capital D is whatever that does not contain a digit. So the whole thing, whole string here does not contain digits, so it'll basically just print the whole string here. Um So it'll print including the spaces as well, because the spaces also don't include digits technically. So it'll just print all of that. And the slash s will print every part that has white space characters or just like spaces here, 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 here. So it'll just print like these four things. And then same thing, the capital version of that will print every non-white space character. So in this string, whatever is just not white, it'll just print everything. So it'll print all the letters essentially. And then the slash W, it will it will return a match from every character that is from lowercase a to z to uppercase a to z, and digits from 0 to 9, and just literally everything. So I'll just get this, and notice that it doesn't really print the spaces, so just print out all the words. And then same thing here, the capital W um will will print out the white spaces because it is contradicting the letters. So it'll just print out all the white spaces here. Okay. And then /z refers to, so it will check if the string ends with a certain letter. So there's no lowercase for z, it's just uppercase z. So this will check that the string ends with Spain here. Yeah, and because the string does end with Spain, it'll say yes, there's a match. Okay, yeah. So again, special sequences, keep this in mind as well, just like the meta characters. These will come in handy as well. Okay. Sets are contained within the square brackets, and what this does is whatever like characters you list in here, it'll check um that there are letters that match with this. So it'll look for all the A's, all the R's, all the N's, in like left to right order. So it'll check for the R. So this character, so it'll look for these three characters in this order. So first there's a R and then the A and so on and so forth. So that's ARN. And then sorry, let me just, okay. So this will look for all the characters in between A through N. So including A and N, it'll look for everything in this order, same thing as before. And then if you have like the caret sign in front of the ARN, it'll look for every character, including the white spaces, other than the ARN. So it'll print out everything that is not ARN. Okay. And okay. So due to time, I'll just go over this. I think it's pretty self-explanatory. So 0, 1, 2, 3 returns like the specified digits, and then this will return every digit between 0 through 9. And if you have like the two square brackets here, it'll look for everything between 0, 0 and 5, 9. So it'll be like one digit here and one digit here, and if it's single digit, then there'll be 0 here, and then just whatever digit is here. And this will look for every lowercase and uppercase. And this one will look for just any matches in the the plus sign. And these don't really have any special meaning, so it'll just whatever character you put in here, it'll look for. Okay. The find all function. Um, Again, we kind of went over this earlier, so it'll just look for everything here. So it'll look for everything that has AI. So Rain has AI and Spain has AI, so it'll just find all the occurrences of that AI. Yeah, so we kind of talked about this earlier. And yeah, so this is just another example of it. There's no Portugal anywhere here, so it'll just have no match. And then the search function, it's similar but different than the find all. So find all looks for everything, but search in this case looks for the white space character, like the specific position of the character. So here it'll look for search. It'll say search, and then it'll have /s, meaning it'll look for the first white space character, because before in the meta characters we said that this looks for the white characters, right? And the search will look for the first occurrence of that. So again, if we count at 0, 1, 2, 3, so this is the first occurrence of that, so it'll say 3. Okay. um okay. And if in this case again there's no Portugal anywhere here, so it'll just say none or something like that. And then the split function, literally just as the word suggests, it just splits everything up. So in this case, the slash s refers to white space characters. So just basically just list off every word that does not include the white space character. So just separate this, this, and that. Okay. Um, then okay. So if you look at this one, this is a little bit different. Um, so notice there's a number here. So what this does is it splits the string at the very first white space character. So the first one here is this, and then it'll just split it once here, and then so this will be one, and all of this will be one. So if you look at here, it's just this, and then all of this, right? And then um okay, I'll just try to finish up real quick. The sub function replaces the matches of like so sorry, let me just load this. Okay. So again, if you look at slash s, that looks for all the white space characters, and it replaces everything with 9 in this case. So all the blank spaces here will be replaced with 9s, because that's how the code basically works. So this is the syntax for it. Just remember the order. Um, before when we did the spacing, um the number was at the back, but when we do sub or like replacing, then number is here. So you can replace it with like any number, or just you can like have a long list of things to replace the blank spaces. Okay. And okay, so again, when we have the number in the back, it typically refers to like the first two, or like the first one, or things like that. So because there's a two here, it refers to the one and two. And what this will do is it will replace only the first two white spaces with 9. So if you look at what is printed, it is this. Okay, and then okay, the search function returns match objects. So meaning this is the text, and it'll search for the AIs. So AI, and it'll print this. So what this does, it kind of counts what position it is at. So it's gonna be 0, 1, 2, 3, 4, 5, and then yeah. So that's the 5, and then this is kind of like the computer language version of it, but yes. And okay, so the match object has properties and methods used to retrieve information about the search and the results. So this dot span returns tuples containing the start and the end of the position, and dot string returns a string passed into the function, and dot group returns the part of the string where there was a match. Okay. So just keep these in mind. You can use it like just like the search methods and things like that. So just remember what each of the things do. Just a couple more examples. Okay. So notice the slash b and the slash w here. So what this does is it searches for the uppercase S at the beginning of a word, because the slash b is at the beginning, and it will print its positions. So because that's what the search does. So it'll look for the uppercase S, so here, and it'll print that position. So this is 12. And then yes, yeah, so that's all for this example. And okay. So next one is the string property returns the search string. So what this does is when we looked at the string here, so remember that this dot string returns the string passed into the function, right? So same thing here, except it'll return the whole string. So it'll just return the rain in Spain in this case. Okay, and yeah, last one. Okay, search for, so what this does is it searches for the uppercase S and it prints out the word. Um, so the group function basically just groups it up. So in this case, it'll just group it up by a word. So it searches for the uppercase S and it just groups the whole word. So it'll just print out Spain in this case. Okay. Yeah, so that's all for me. And I'll pass it off and then we'll give you guys the homework.
Yeah, I'll be doing that. Give me 1 second. Don't really want to take up any more of your time, so I'm just gonna do this quickly. Okay, so your homework for this for today is going to be coding bat again. Remember codingbat.com, and it's going to be logic 1, so right here. String 1, which is over here, and then list 1 over here. Basically just complete all the problems in each one of these like groups, and then make sure to send them to like your little homework channel once you're finished with them. And yeah, that's basically the homework. So if nobody has any more questions to ask or anything, then I think we're basically done for today. So yeah, bye.